Hey everyone, and welcome back to OpsCraft. We've all seen the videos. AI is amazing. It's generating text, code, and images with incredible ease. But for us in engineering, the real challenge is not using the AI, it's integrating it. It's about how to get the power of the world's best AI models into our own applications without rebuilding our entire infrastructure. The reality is, connecting to and managing multiple AI models is a headache of API keys, custom code, and vendor lock-in. It's messy, it's slow, and it's expensive. What if there was a better way? A single, elegant front door to all of the leading foundation models. That's what Amazon Bedrock promises to be. But to truly understand it, we need to go beyond the marketing and break down the core concepts. And trust me, it's more than just a unified API. First, let's talk about Bedrock's core value, a unified gateway. Think of it like this. If you wanted to build an application that used a text model from Anthropic and an image generation model from Stability AI, you'd have to sign up for 2 different accounts, manage 2 different sets of billing, and write custom code for each one. Bedrock brings all of these models together under a single unified AWS service. This gives us incredible flexibility, preventing vendor lock-in and simplifying our entire infrastructure stack. This brings us to our next key concept, the difference between foundation models and base models. A foundation model, or FM, is the core technology, a massive pre-trained neural network. A base model is a foundation model that is packaged by a provider and ready to use out of the box. So, when you see a model like Amazon Titan or Anthropic's Claude 3, you are looking at a ready-to-use base model that lives under the umbrella of a foundation model. Bedrock gives you a variety of these industry-leading base models to choose from. Now let's talk about how we communicate with these models. When you send a prompt to a model, you're not actually sending words. You're sending tokens. Think of tokens as the building blocks of language. They can be a word, a part of a word, or even a punctuation mark. The model processes these tokens during inference, which is the process of generating a new response. The speed and cost of your application are directly related to the number of tokens in both your prompt and the generated response. To get the response you want, you have to master inference parameters. These are the settings that control the model's behavior. The most critical one is temperature, which controls the creativity of the model. For a factual task like writing a technical report, you'd want a low temperature, like 0.1, to ensure predictable results. For a creative task, like brainstorming marketing copy, a high temperature, like 0.9, will give you more varied and surprising responses. Another key parameter is max output tokens, which limits the length of the model's response, helping you control cost and speed. Finally, a concept that is foundational to more advanced use cases, embeddings. An embedding is a numerical representation of text. It's how a computer can understand the meaning and context of words. Bedrock can take text and convert it into a vector, which is a list of numbers. Why is this important? Because it allows you to do things like find semantic similarity. You can take a user's question and use embeddings to find the most relevant documents in your entire company database, which is a core part of building a smarter AI application. We'll be diving deeper into this in our next video. So Bedrock is much more than just a single API. It's a powerful platform built on these core concepts. We've covered foundation and base models, tokens, inference, and key parameters. But we've only scratched the surface. In our next video, we'll dive into the advanced features that make Bedrock a true production-ready service, including agents, knowledge bases, and RAG. Subscribe now so you don't miss it.